Hi folks, I hope you're having a really good day. Today we're going to look at the difference between finding a significant linear correlation where we are allowed to use the regression equation and one that is not significant where we need to use the average y value. So you can pause the video for just a moment and make sure that you have your calculator, and also make sure that you have your handy dandy half sheet of the critical values for our regression coefficient R. Okay, so now pause the video for just a moment and put the length of bears in list 1 and put the weight of bears in list 2. We want to know if we're allowed to use a regression equation to predict the average weight based on the relationship between length and weight. Okay, so now you should have been able to get the length of the bears in list 1 and the weight of the bears in list 2 is the relationship between the length in inches and the weight in pounds. So stat, calc, linreg, make sure you have list 1 and list 2, and this is what we get. So write down your R value and then check to see how many pairs of data we have. 1, 2, 3, 4, 5 pairs of data. Pull out our handy dandy chart and go down to n equals 5 and then over to the first column, and our table value is 0.878. So then we're going to check, is R bigger than the table value? The absolute value of R is greater than the table value. So yes, can we use the regression equation? Yes, we can. So let's do that. So what if the length of a bear is 58 inches and I want to know the weight of the bear? So pull your calculator back out and let's write down the equation. Y equals mx plus b. Okay. 12.3x minus 467.8. The height, or the length, is 58 inches. So 12.3 times 58 inches minus 467.8, and you should have 245.6 pounds. Let's just round it off to the nearest pound. So about 246 pounds. So if R is bigger than the chart, we definitely can use the regression equation. Okay, so what happens if R is not bigger than the chart? Now put body temperatures at 8 o'clock in the morning in list 1 and put body temperatures at night in list 2. And pause your video. Okay, now that you have your body temperatures at 8 o'clock in the morning in list 1 and your body temperature at midnight in list 2, let's do the linear regression. Stat, calc, linreg, list 1, list 2. Okay, so the first thing that we write down is R. R equals negative 0.254. How many pairs of data did we have? 1, 2, 3, 4, 5, 6. And then pull out your handy dandy table. Go down to 6 and enter your value, your table value. Okay. So now we're checking to see, is the absolute value of R greater or smaller than the table? The absolute value of R is smaller than the table, so no. Even though we have a regression equation, we don't get to use it. Instead, we are going to use the average of your Y values. So, find the body temperature at midnight if the 8 a.m. temperature is 98.0 degrees. Okay, don't use your regression equation. Instead, find the average Y value or the average temperature at midnight. So, pull your calculator back out. We have data in list 1 and list 2. Midnight is list 2, so I want to average list 2. Stat, calc, one variable stats with list 2. So our average is 98.45. So if your temperature at 8 o'clock in the morning is 98, your temperature at midnight is most likely 98.45. But if your temperature in the morning is 98.3 or 98.6 or 97.9, our best guess for your evening temperature is still 98.45, no matter what value that we are trying to estimate. And do not plug it into the regression equation because R is smaller than your table value, and so we don't get to use it. Okay, so now there's a couple of questions here at the end that you're going to answer. And I hope you have a beautiful day.